Hello and welcome into the example video for lesson 15 for Precalculus 1. We're going to look at a bunch of examples here, hopefully enough to give you a really good idea what you're doing on the mastery sets, what you're doing on the in-class assignments. Let me share the document camera here for you. All right, so the first set of problems we want to evaluate the functions, and let's round to 3 decimal places. So the first one, our function f of x is equal to 3 to the x power. The first thing I want to figure out or evaluate is f of 2. So the way we work with functions is still the same. I'm just plugging 2 into the function anywhere I have an x, which is what? 3 to the second power. And 3 to the second power is 9. So to 3 decimal places, 9.000. What if I have f of 0? Well, this means 3 to the 0 power. Anything to the 0 power is what? 1. So 1.000. What if I have f of 1/2? Well, that means what? That means 3 to the 1/2 power. If you think back to day 1 or 2, I guess, anything to the 1/2 power means what? Square root. So this is asking me what is the square root of 3? So if you do that on your calculator, you should get like 1.732 to 3 decimal places. That's how you would do those. What if my f of x is equal to 2 to the x plus 1 power? All right. So what if I have f of 1? Well, that means it's 2 to the 1 plus 1 power, which is 2 to the second power, which is 4. So again, if we're doing the 3 decimals, make sure you put those zeros on there for WebAssign. It might take 4, but just if it's not, that's why. Make sure you put the 3 decimals. What if I have f of 0? Well, that's 2 to the 0 plus 1 power. So 2 to the first power, which is just 2. And how about f of minus 1? So I plug that in, I get 2 to the negative 1 plus 1, which is 0. Anything again to the 0 power is just 1. And then lastly, our natural exponential function. If we have f of x is equal to e to the x power. If I want f of 1, that means e to the first power. And so depending on your calculator, there might be different ways you have to do this. Like the calculator I use, the way I have to enter this is first I hit 1, and then I hit my e to the x button. And that'll kick out the number, which rounded to 3 decimal places would be 2.718. And again, your calculator might be different. If you have a stack calculator, which is like you enter it kind of what the problem looks like, you might have to do like the e to the x button, and then it'll give you like somewhere to enter the number, and then maybe you hit 1 and then like enter or something like that. Depending on your calculator, there's going to be different keystrokes, but hopefully you can figure it out here in these practice problems. So on the mastery and the in-class, you can do it. So f of minus 4. So try that one on your calculator. And the value you should get to 3 decimal places should be 0.018. Again, it's not negative just because this is negative. That just means the exponent is negative. And what about f of square root of 3? So again, you're going to do 3 square root and then e to the x button or something like that. And you should get 5.652. So that is how you evaluate exponential functions. Next type of problem. Express in log form. So we're going to be given an exponential and we have to write it with the log function. And this is our basic log property. So if I have 3 to the third power is 27. So let's remember, what was the basic log property? It said log base a of x equals y is the same as a to the y power is equal to x. So if that's the case, in this case, this is my a, this is my y, and this is the x. So therefore, in terms of logs, it's going to be log base 3 of 27 is equal to 3. That's how we write it in log form. Take this exponential equation, turn it into a log equation. So try this one. 6 to the fourth power is 1296. So see if you can write that one in log form. So 6 is my base. So log base 6. I end up with this number, 1296. And that's because 6 to the fourth power is 1296. What if we want to express in exponential form? So now going the other way. So we're given log base 3 of 9 is equal to 2. Well, without the log function, this is the same as what? 3 squared equals 9. Or if I have log base 6 of 36 is also equal to 2. Why? Because 6 squared is equal to 36. What if I have log base 6 of 1/6 is equal to -1? Well, that's because 6 to the negative first power is equal to 1/6. So that's how we're going from exponential log form into exponential form. All right. What if we want to evaluate these different log expressions? So first I have log base 4 of 1. Well, you can do this two ways. You can go back and look at your log properties and say, oh, anything log base a of 1 is equal to what? It's equal to 0. But if we didn't know that log property, let's say this is on a test and it's like, you know what? I just didn't have time to memorize those properties. Let me do it myself. So we're trying to find what goes in the box. So by our basic log property, that means what? 4 to what power is equal to 1? Well, anything to the 0 power is 1. Therefore, this answer is 0. What if I have log base 4 of 256? So go ahead and try that one. So this is asking me what? 4 to what power is 256? Well, 4 to the fourth power is 256. And how about log base 8 of 8 to the 15th power? All right, so this one, again, you could use your log properties. And if you do, you know the answer right away. If not, let's say we're trying to figure out, okay, what goes in this box? Well, it means what? 8 to what power is equal to this guy? 8 to the 15th. Well, the only way these two sides are equal is what? If there's a 15 in the box here. So this answer is 15. All right, moving on. So find the domain and write in interval notation. So the first one we have f of x is equal to log of x plus 2. All right, so to find domains of logs, we do what? We take this guy here, x plus 2, and make it just greater than 0. So if I subtract 2, that means x is greater than -2. So in interval notation, that's -2 to infinity with parentheses on both. What if I have g of x is equal to the natural log of x plus the natural log of 4 minus x? Uh-oh, I got two of them. So what? So you got to do two of them and find the overlap, just like we were doing when we had um, even root and a denominator. You found the domain of the even root. You found the domain of the denominator. Where are they overlapping? Same thing. First, this one. The domain of just this first piece is that x is greater than 0. Okay, that's easy enough. And for this one, the domain is 4 minus x is greater than 0. So if I subtract 4, I get negative x is greater than -4. Divide by -1, so reverse the inequality, x is less than 4. So if I want to look on a number line, I have 0 with an open circle going this way. I have 4 with an open circle going this way. So the overlap is what? 0 to 4 with open circles on both ends. So that is your domain for that one. And lastly, let's say h of x is equal to log base 5 of 8 minus 4x. So go ahead and try that one. Hopefully you hit pause, worked it, you're back. So it means what? 8 minus 4x is greater than 0. So minus 8. Get -4x is greater than -8. Divide by -4. So reverse the inequality. X is less than +2. So that's what? -infinity to +2, not included because it's strictly less than. All right, next. We want to evaluate. So we have log base 2 of 15. So this is what we had before, just one piece, but now we have minus log base 2 of 12 minus log base 2 of 20. So we're going to have to do what? Use our law of logs. And so just work left to right. So I have a minus sign here. So that's what? Division. So these first two terms I can combine into log base 2 of 15 over 12. And then minus log base 2 of 20. And now you have to be careful because you're going to have a fraction with a bunch of different parts. So this is again division. So it's what? Log base 2 of 15 over 12 divided by this guy, 20. Or if we want to say 20 over 1. So to simplify this, I can do what? Keep change flip. So this is log of 15 over 12 times 1 over 20. So simplify this. 15 divided by 5 is 3. 20 divided by 5 is 4. 12 divided by 3 is 4. 3 divided by 3 is 1. So this is the same as log base 2 of 1 over 16. So this means what by our basic log property? 2 to what power is equal to 1 over 16? Well, this is the same as what? 1 over 2 to the 4th power, right? 2 to the 4th power is 16. So if I flip this using my exponent rules from day number 2, this is like 2 to the minus 4th power. So the only way that these two pieces are equal to each other is if the exponents are equal. So my answer then is minus 4. So a little long, a little tricky math, but that's our process. What if we have log base 2 of 10 minus log base 2 of 30 plus log base 2 of 96? Well, again, I'm going to combine these first two with division. So it's log base 2 of 10 over 30, which is log base 2 of 1/3, plus log base 2 of 96. And now the plus means multiply. So this is log base 2 of 1/3 times 96, or 96 divided by 3, which is what? Log base 2 of 32. So 2 to what power is 32? 5. 2 to the 5th power is 32, so therefore log base 2 of 32 is 5. So that's how we use our law of logs to combine these pieces, and then use your basic log property to simplify. And then to wrap up this video, we're just going to use our law of logs to expand or combine different expressions. So use laws of logs to expand or combine. So the first one we have is log base 3 of 7r. So we're going to expand this. This is multiplication, which means what? Addition. So log base 3 of 7 plus log base 3 of r. And that's it. That's all we're doing. We're just breaking this guy apart. What if I have log base 7 of xy to the 8th power? All right, so first thing we're going to do is use our third law and move this 8 out into the front. So this really means the same thing as log base 7 of x times y. And this is where you have to be careful with either your distribution or your parentheses. So this guy here is just simply what? The addition. So log base 7x plus log base 7y, but there's this 8 out in front multiplying everything. So either you need to have an 8 out in front with parentheses, or you need to distribute the 8 to both of those pieces. I would just leave it like this. Leave it 8 times that whole piece. And what if we have log of square root of x divided by 3? All right, well, first we have to use our exponent rules to convert this to what? Log of x over 3 to the 1/2 power. Square root is 1/2 power. Bring it in front means it's 1/2 times log of x over 3. And x over 3 is division, meaning what? Subtraction. So it's 1/2 times log of x minus log of 3. Well, that's our different variations on expansion. And then what if we want to combine? So what if I have log base 4 of 2 plus 2 log base 4 of 9? Well, for this second one, the first thing I need to do is use my exponent rule, the exponent law number 3, and take this up to the top. So this is log base 4 of 2 plus log base 4 of 9 squared, which is 81. And now that it's addition, I do what? I multiply these two pieces. So this becomes log base 4 of 2 times 81, which is 162. What if I have log of a plus b plus log of a minus b minus 2 log of c? All right, well, these first two, it's addition, so I can multiply them. So this is log of a plus b times a minus b. Well, that's what? That's a difference of squares. If I FOIL this, this guy is really what? Log of a squared minus b squared. And then I have this piece here. If I take the 2 up for my exponent, this is minus log of c squared. And so because it's subtraction, I can do division. So this just becomes what? Log of a squared minus b squared, all divided by c squared. So that's it. A bunch of different types of examples for you guys. Hopefully those are enough to get you through everything. If not, let me know. We can always work more examples in class if needed. Otherwise, come on back. We will look at lesson 16, which will be the last lesson that we do for this semester.